All right, guys, we're doing lesson 19. This is solutions to inequalities in one variable. So here what we're going to do, we're matching words and symbols. For each inequality, write 3 values that make the inequality true. Write 3 values that make it false, and then choose a verbal description that matches the inequality. So let's see here, 3 values that make it true. Let's just pick some big numbers. So we have x is this sign, 13.5. So we're going to say, let's say 20, let's say 1,000 or 100. Well, let's say 1,000. And then we'll say 1, let's say here. I'll just say 100. Okay. 3 values that make it false. 0, -2, 10. Which verbal description best matches the inequality? So we have 1, 2, or 3. Those are like Roman numerals. So we have x is greater than 13.5. Okay. This next one, I want you guys to do number 2 at your tables. Okay. You can do it with whoever's sitting next to you. If you have somebody at your table with you, make sure you are not talking across the room. It needs to be at your table. Okay. Let's see here. Now we have x is, let's see here. It's going to be more than or equal to 1/2. Or it's going to be less than, and it is going to be less than 2.75. So 3 values that make that true. So let's see here. We could say, so 1/2 is an option. 1 is an option. 2.75 is also an option. And then 3 values that make it false. 10. Let's see here. What about 0? And let's do 3. So which verbal description best matches the inequality? Is x in between 1/2 and 2.75? Is 2.75 is less than x is less than 1/2? Or is x greater than 1/2? We're going to go with the first one. Okay, let's go to the next page. Find a value, any value. Write some solutions to the inequality. And be prepared to explain what makes a value a solution to this inequality. So, let's see here. So y could be 8. Y could be 9. Y could be 9.2. Y could be 0. Y could be 1. Let's pick one more. Let's say 5. So what makes a value a solution to this inequality? It just has to be less than or equal to 9.2. Anything less than or equal to 9.2. We could have negative numbers. We could have -10. We could have anything there as long as it is less than 9.2. All right, now we're going to write one solution to the inequality and be prepared to explain your reasoning. So, let's just solve it. If we have this, let's divide by 7 here. So we're going to get 3 minus x equals 14 divided by 7 is 2. We're going to subtract 3 from both sides. So we'll get net, and actually I need to leave that as a greater than sign. So we'll have negative x is greater than -1. So if I have negative x is greater than -1, I know that was really small down there, so that's why I'm running it to the side. We divide by -1 to get rid of that negative. We will have x is greater than 1. So any value that is greater than 1 will make this inequality true. So we can say x equals 2. Let's say 10, 30, If I plug in any of those values, then, oh wait, I divided by a negative. Let's see why I did this wrong. This is why you flip your sign whenever you divide by a negative. It's been a while since we've done this. So if I plug in a 2, if I have 7 times 3 minus 2 is greater than 14. We have 7 times 1. Is 7 greater than 14? No. So here's what we need to do. We divided by a negative 1. So that means we flip our sign. So I'm going to erase all this over here. And I'm sorry if you did this in pen. You should be doing this in pencil. So you can erase. If you need to pause here. And I'm going to keep going. So x actually needs to be less than 1. So if x equals 0 or negative 3, it'll work. So if we have 7 times 3 minus negative 3 is greater than 14. Remember that you have to change this to be a plus 3 because you have 2 negatives there. So we will get 7 times 6 is greater than 14. I know that's going to be greater than 14 because 7 times 2 is 14. But 7 times 6 is 42. So that made a true inequality. All right. The best way to check your answers with these is to plug in values. Okay. All right, now we have off to an orchard. A teacher is choosing 2 options for a class field trip to an orchard. At Orchard A, admission costs $9 per person and 3 chaperones are required. At Orchard B, the cost is $10 per person, but only 1 chaperone is required. At each orchard, the same price applies to both chaperones and students. Which orchard would be cheaper to visit if the class has 10 students? So, on the left, I'm going to do Orchard A. And on the right, I'm going to do Orchard B. Okay? So at Orchard A, it's $9 per person, and there are 3 chaperones. So I need to do, so we have 10 students, so we're going to do 10 students plus 3 chaperones times by $9 per person. So we will have 9 times 13, which equals, I don't remember that one off the top of my head, so I'm just going to do it over here. 9 times 3 is 27. 9, 10, 11. Is that right? 12. 127. Okay, so it's $127 for 10 students. Orchard B, we have only 1 chaperone is needed, so we're going to have 10 students plus 1 chaperone. We're going to times it by 10. So we have 10 times 11 is 110. So which one was cheaper? Orchard B, because we have 127 and 110. So we would want to go to Orchard B if we only had 10 students. Okay, so what if we have 30 students? So again, we're going to multiply 9 by 30 plus 3. So we will have 9 times 33. Again, I'm going to do this to the side over here because I don't know this off the top of my head. 9 times 3 is 27. So 27, 28, 29. So it's 293. Oops. 293. Orchard B. So again, we're going to do 10 times 30 plus 3. And then 10 times 33, because we're adding those together. Then we're just going to add a 0, so $330. Now we have Orchard A. Orchard A being cheaper. Okay? To help her compare the cost of the two options, the teacher first writes the equation 9 times the quantity of n plus 3, so n being the number of students, and 10 equals 10 times the quantity of n plus 1. Then she writes these values as an inequality. So n represents the number of students. Okay? In this situation, what does the equation, so we have 9 times the quantity of n plus 3 equals 10 times the quantity of n plus 1. This is going to mean this is at this value of n, the orchards cost the same. Okay? What does the solution to the inequality, so 9 times the quantity of n plus 3, is less than 10 times the quantity of n plus 1, tell us? So, that means that for these values of n students, orchard A will cost less than orchard B. All right, so if you need to pause to write all this down, make sure you have this in your notes. I'm going to keep going to the next page. So now we're going to graph this. We're going to graph the solution to the inequality on the number line. Let me go back one second. It doesn't tell me to solve for it right here, does it? It does not. So I'm going to write it over here to the side. So we had 9 times n plus 3 equals or less than 10 times n plus 1. So I'm going to solve for 1. So first thing I'm going to do, in this case I don't, like earlier whenever I just divided by the number, here is not a good option to do that because we have parentheses on both sides. So we're going to distribute into the parentheses. So we're going to have 9n plus 27 equals 10n plus 10. Now we're going to solve for n. Here is where you want to pay attention to what you're doing. So we don't have to divide by a negative. The best thing to do here is to recognize that this n is less than this n, okay? And this whole number is less than this whole number. So if we move those to the opposite sides, we're going to keep positives. So what we're going to do is we're going to subtract the 9n from both sides. So we get 27 equals n plus 10, subtract 10 from both sides, and n equals, let's see here, that is 17. So at 17, the orchards are going to be the same cost. So for 17 students. So over here, we're supposed to graph the inequality on the number line. So we need to go to, actually, I'm just going to put 17 right here. Okay. And we can say that for 17 students, or for less than 17 students, because all you have to do is just change this. But let's see here. Let's plug in a value and see if it's true. So let's plug in, or no, actually we already did that. We did that up here. So 10 and 30. And Orchard B was cheaper for 10. Okay. So we want orchard A to be cheap, or to cost more, right? Let's see here, because our inequality says orchard A is less than orchard B. That's what our inequality says. So we want to go toward, let's see here, how do I want to do this? Orchard A to be less than orchard B, we need to go toward the right to make that inequality up there true. So orchard A will be less than orchard B from 17 students, not including that point. If it were including that point, we would have the equal sign underneath it. So we want our graph to go this way. Notice that that is not the same direction as my inequality. Okay? It is going the opposite direction. So you have to make sure that you can plug in your values and determine if it's true. So that's what I was doing down here with the orchard B and the orchard A with the 10 and the 30. Okay? So for less than 10, it makes that inequality false. Less than 17, it makes the inequality false. So over here where we have 10, let's say that's 10. This is just a guesstimate. It's not it's approximate. It's not like precise. So for 10, it is false because orchard B would be less. And over here, let's say 30 is way down here, it will be true. Orchard A will cost less per person, or cost less overall. It does cost less per person, but it will be less overall because of the chaperones, right? Okay, next one. Part-time work. Let's see here. So, to help pay for his tuition, a college student plans to work in the evenings and on weekends. He has been offered 2 part-time jobs, working in the guest service department of a hotel and waiting tables at a popular restaurant. The job at the hotel pays $18 an hour and offers $33 in transportation allowance per month. The job at the restaurant pays $7.50 an hour plus tips. The entire waitstaff typically collects about $50 in tips each hour. Tips are divided equally among the 4 waitstaff members who share a shift. The equation 750H plus 50 divided by 4H equals 18H plus 33 represents a possible constraint about the situation. So we're going to solve this equation here and then check our solution. So I'm going to zoom in a little bit more here. So first thing I'm going to do is I'm going to do this right here. I'm going to do 50 divided by 4. Okay, so 4 goes into 5 one time, leaves me with 1. So I'll have 10 divided by 4 is 2. That'll be 8 is what comes out of that. So I'll have 2 left. And then 5 is what will be left because 20 divided by 4 is 5. So I'm going to change this to be 750H plus 1250H equals 18H plus 33. I'm going to combine these two right here. It's going to be 20H equals 18H plus 33. Then we will subtract 18H from both sides. That goes away. And I know that looks kind of like an N in some places, so I'm going to do this. H is 33. Divide by our 2. And H equals 1. Should be So 33 divided by 2, that's going to be 13 left over, so 16.5. All right, so graph it here on the number line, so we're just going to put 16.5 right here. And then, I believe when I did this last time, we did 17, 17.5, 18, 18.5, 19. And then going down, we'll have 16, 15.5, 15, 14.5, and 14. So there's our scale, so that the circle represents the solution. It's all graphed. So the student works, so does one job pay better if the student worked fewer hours than the solution you found earlier? So basically what you're going to do here is you're just going to plug in a number. So if, let's say, student works, let's say H equals 10 hours, because I like nice even numbers. It makes it a little easier to do the math. So I'm going to just plug it in. So let's do let's just do 20 times 10. This is for the restaurant. So they will make $200 at the restaurant. Okay. So what about at the hotel? Let's do 18 times 10 plus 33. 18 times 10 is 180 plus 33. We get $213 at the hotel. So which one paid more? The hotel did. Hotel pays more for 10 or for less than 16.5 hours. Okay, so what about if he works more hours? So again, let's pick a pretty easy number. Let's just pick, this time let's do H equals 20. So again, we'll do 20 times 20. You get 400 at the restaurant. Okay, do 18 times 20 plus 33. 18 times 20 is 360 plus 33. That is going to be $393. So at the hotel. Restaurant pays more for more than 16.5 hours. All right, pause here if you need to, but I'm going to the next page. All right. We're going to finish up 19.3 today, and then tomorrow we will finish up 19.4 when we do lesson 20. So, here are two inequalities and two graphs that represent the solutions to the inequalities. So, first you have to find out what each equation is saying. So, we're saying the restaurant pays less than the hotel for the first one. So we have to look back at our previous page. The hotel pays less than the restaurant. The restaurant pays less than the hotel. So the hotel is paying more on this one for less than 16.5 hours. So that's going to be my graph B. So the restaurant pays less than hotel. So if we put our number scale down here that we did on the previous page, it's just 16, 15, 14, 17, 18, 19, 14.5, 15.5, 17.5, 18.5. The next one we have is saying the hotel pays more than or is greater than the rest, or sorry, I keep wanting to say hotel first. The restaurant pays more than the hotel. So that is going to be A. So the restaurant is greater than the hotel. So 16.5, again, make sure your scales are in here. And then we have 17, 17.5, 18, 18.5, 19, 16, 15.5, 15, 14.5, and 13. Not 13, 14. So that should cover everything here that we were supposed to do for this part. And actually, I think you guys should try this. So today in class, whenever you're done with this video, because you will have some time, I want you to work on doing 19.4, 19.5. Yeah, I think that you guys can do these two, okay? Send me an email if you have any questions, and work on your practice problems as well. You should be busy this entire hour. I will be back tomorrow. So I'll see you then.